This protocol uses a grooved parallel plate waveguide to measure the refractive index of a microfluidic sample at terahertz frequencies. First, design and fabricate the grooved waveguide to exhibit a resonance in the terahertz range. Then, using a terahertz time domain spectroscopy system, measure the resonant frequency of the waveguide. Next, fill the waveguide with a carefully measured volume of the sample fluid. The final step is to measure the resonant frequency of the filled waveguide. Ultimately, the difference between the resonant frequencies for the empty and filled waveguides can be used to determine the refractive index of the sample in the terahertz frequency range.
Generally, individuals new to this method will struggle because of the very high accuracy required to obtain repeatable results. Kim Reichel, another graduate student from Daniel Middleman's laboratory, and I will now demonstrate the procedure.
Design a parallel plate waveguide with one or more integrated cavities or grooves.
Base the geometry on parameters detailed in the accompanying manuscript and also refer to our previous publications. These are a few general guiding principles.
Start with a plate size wide enough that it can be considered infinite compared to the input beam. To allow for easy access to the groove, make the bottom waveguide plate significantly wider than the top plate, so that the groove extends almost the entire width of the plate. Make the propagation length such that the waveguide as a whole is at least 3 times as long as the extent of the groove, and the holes in the bottom plate are threaded, while those in the top are not.
The design for the groove will depend on the desired resonant frequency, the desired line width, and the chosen plate spacing, among other factors. It's important to consider the limitations of your fabrication techniques for very narrow or very shallow grooves.
For use as a reference, also fabricate an identical design lacking a groove.